Minute Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. And today we're going to learn about differentiation. And we're going to apply the quotient rule. We're going to differentiate each function with respect to x. So if I was given this function, y equals 2 over 2x to the fourth minus 5. Okay? So what I want to do here is a lot of times we're going to label what is my f and what is my g. All right, so our function here has two parts, the f, which is a 2, and g, which is 2x to the fourth minus 5. Sometimes what I'll do is I'll quickly just label that. I'll say, okay, f is equal to 2, and g is equal to 2x to the fourth minus 5. And then, even while we're at it, we can say, okay, what's f prime? So I just take what's f prime here. Well, derivative of 2 is 0. And g prime is just, well, take a derivative of this using the power rule. We have 8x to the third. And then not minus anything because derivative of 5 is 0. So now we have our f or g, our f prime and g prime. So now all we need to do is apply the quotient rule. So dy dx is equal to our quotient rule, right? We have our f up top, or g down here, right? That's f over g. So let's plug in our parts. F prime, 0, times g, which is 2x to the fourth minus 5, minus f, which is 2, times g prime, which is 8x to the third, all over g squared, 2x to the fourth minus 5 squared. So now let's simplify that, okay? Well, 0 times this whole part is just 0, so we don't really need that. So we have our dy dx here. That just kind of goes to 0. I'm going to write that out. And then 2 times 8 is 16. It's a negative, so we have negative 16 here, x to the third. And then the denominator, all right, we need to multiply that out. Now, if you want to see a little note here, sometimes I like to do little notes on the side. 2x to the fourth minus 5, all squared. Now we can write it as 2x to the fourth minus 5. If you can't really do this in the head, just write it on the side here, that's fine. And then we're going to multiply this out, distribute out, or FOIL, if you've heard that before. Okay, 2x to the fourth times 2x to the fourth is 4x to the 8th. We add the exponent here. 2 times 5 is a negative 10, so negative 5 to 10, negative 10x to the fourth. Here again, the negative 5 times 2x to the fourth is another negative 10x to the fourth. And then negative 5 times negative 5 is positive 25. We add them together, we have 4x to the 8th minus 20x to the fourth plus 5. And there we have it down here. 4x to the 8th minus 20x to the fourth plus 5. And that actually is just our final answer. We have our derivative now, dy dx is equal to negative 16x to the third over 4x to the 8th minus 20x to the fourth plus 5. F of x is equal to 2 over x to the fifth minus 5. Okay. Well, since I have this function, I can break down to be a function basically divided by another function being 2, other function being x to the fifth minus 5. I can label my top one f, which is 2, and my bottom one g, which is x to the fifth minus 5. Now while I'm at it, I can take the derivative of each one. F prime is just equal to 0, derivative of 2 is 0, and g prime here is, well, derivative of x to the fifth minus 5 is just 5x to the fourth, okay? And so now that we have f prime, g prime, we can apply our quotient rule. The quotient rule is when we take the derivative of a quotient function. So let's apply that quotient rule. F prime of x is equal to, well, f prime, which is 0, times g, which is x to the fifth minus 5, minus f, which is 2, times g prime, which is 5x to the fourth, all over, okay, all over g squared, which is x to the fifth minus 5 squared. So my next step, let's go simplify this. We have f prime of x here. Well, 0 times everything here just cancels it out, right? Or times x to the fifth minus 5 because it's times 0. And then 2 times 5 is 10. It's a negative, so we have a negative 10x to the fourth up top. Now the denominator, a lot of times I'll make a little note on the side to multiply that out, distribute that. Okay, so we have x to the 5th minus 5 all squared. That's x to the 5th minus 5 times x to the 5th minus 5. A lot of 5s here, too many 5s. Multiply about x to the 5th times x to the 5th is x to the 10th. Right, we add the exponents. Minus x to the 5th times negative 5 is a negative 5x to the 5th. Negative 5 times x to the 5th again is a negative 5x to the 5th. And then negative 5 times negative 5 is a positive 25. We keep continuing this. X to the 10th, simplifying here. Negative 5x to the 5th minus negative 5x, or minus 5x to the 5th is negative 10x to the 5th. And we have plus 25. So there we go. So I can write that down here. X to the 10th minus 10x to the 5th plus 25. And there we have it. We can't simplify it anymore, so this is our final answer here. F prime of x is equal to negative 10x to the 4th all over x to the 10th minus 10x to the 5th plus 25. F of x is equal to 5 over 4x to the 3rd plus 4. Okay? Well, since I have a quotient function here, right, a function divided by a function, I'm going to apply the quotient rule. So I'm going to label the top part, the numerator, f, which is 5 here, and my denominator, g, which is 4x to the 3rd plus 4. Then I'm going to find f prime. F prime is just equal to 0, and g prime is equal to, using the power rule, 12x squared. So now I have f, g, f prime, and g prime. I can apply the quotient rule to my original function, and it's written right up there. So, and plug in basically my parts. So f prime of x is equal to, well, f prime, which is 0, times g, which is 4x to the 3rd plus 4, minus f, which is 5, times g prime, which is 12x squared. All over here, okay? Well, all over g squared, sorry. 4x to the 3rd plus 4 all squared. Okay? So now we're going to simplify that. Well, if f prime of x here is equal to, well, 0 times 4x to the 3rd plus 4, that just becomes 0, so we can cancel that out. And negative 5 times 12 is negative 60, so we have negative 60x squared. All over my denominator, I'm going to simplify right there. So we have 4x to the 3rd plus 4 all squared. Multiply that out, that's 4x to the 3rd plus 4 times 4x to the 3rd plus 4. Multiply that out, 4x to the 3rd times 4x to the 3rd is 16x to the 6th power, we add the exponents. And then 4x to the 3rd times 4 is 16x to the 3rd. Same thing here, 4 times 4x to the 3rd is 16x to the 3rd. And 4 times 4 is 16. Okay? Now, one thing we notice here, okay, I hope you can see, is that there's a 16 in all parts. So when I'm simplifying this, I have 16x to the 6 plus, we add these together, that's 32x to the 3rd plus 16. And I know I can pull out a 16 for everything here, okay? Well, what I'm also going to think about is say, okay, what can I pull out here? What can I pull out that is divisible by that 60, okay? What common number? Because I know 2 can go into 60. What about 4? 4 can go into all of these. And that gives me 60 divided by 4, 15, right? 60 divided by 4 is 15. Okay, so if I pull, right, yeah, 15. So if I pull 4 out here, 4, I'm left with 4x to the 6th plus 8x to the 3rd plus 4. Okay? And now you might say, well, you can keep pulling out more, and you can. I'm kind of knowing the future, what's going to happen here. Okay? So if I write that up here, 4 times 4x to the 6th plus 8x to the 3rd plus 4. Well, the 4 can be canceled out with the 60, giving me 15. Okay? 15 up there. Now, I could have pulled more out. I could have pulled another 2 out of there and got me 2x to the 6th plus 4x to the 3rd plus 2. but 2 doesn't go into 15. And there's nothing else I could have pulled out that would have canceled that or simplified that anymore. Okay, so I kind of knew that ahead of time when I plugged that back in, just so you know. But I normally would have just tried them all, like pulled as much out as possible, see as much as I canceled, and distributed really back in at the end. But now I have my final answer, which is f prime of x is equal to negative 15x squared, all over now my denominator, 4x to the 6th, plus 8x to the 3rd, plus 4. And that's it in simplified form. Y equals 4x to the 3rd minus 3x squared, all over 4x to the 5th minus 4. Okay? Well, since I have a quotient function here, I'm going to label the top part f, the numerator f, 4x to the 3rd minus 3x squared. But my denominator g, 4x to the 5th minus 4. Then I'm going to find f prime from there. So f prime is 12x squared minus 6x. And my g prime here is 20x to the 4th. Okay? 20x to the 4th. So now I have f prime, g prime. I can apply the quotient rule. So I'm taking my derivative, dy dx. And that's going to equal f prime, 12x squared minus 6x, times g, which is 4x to the 5th minus 4, minus f, which is 4x to the 3rd minus 3x squared, times g prime, which is 20x to the 4th, all over here g squared, which is 4x to the 5th minus 4 squared. Okay? A lot written out here, so now I needed to distribute. I'm going to distribute all parts up there. Okay, so we have dy dx, my derivative. Well, 12 times 4 is, oh my goodness, 36. 12 times 4 is 60, right? 4, no, not 60. 48. 48. Can't believe I said 60. 48. X to the, we add the exponents, 7th power. 12 times 4 again is a negative 48x squared. Negative 6 times 4 is a negative 24. We add the exponents x to the 6th power. And negative 6 times 6x times negative 4 is a positive 24x. Now, when we subtract here, we have to remember that subtraction gets distributed to both parts. Okay? So 4 times 20 is 80. So we have 80 x we add to the 7th power, but a subtraction going in there. Then that subtraction goes with this subtraction, right? We subtract that subtraction of both parts right there, right? Makes an addition. So we add 3x squared times 20x to the 4th. That's 60 here, x to the 6th power. All over, now my denominator, make a little note here, 4x to the 5th minus 4 times 4x to the 5th minus 4. Distribute that out. 4 times 4x to 4 times 4 is 16, and then x to the 10th power. Multiply that, we have 16x to the 5th, negative 16x to the 5th, and a positive 16. Simplify that, we have 16x to the 10th minus 32x to the 5th plus 16. Okay, so I'm going to write that out here. Okay, now what I can try to do here is I'm also, well, I'll write it out here, 16x to the 10th minus 32x to the 5th plus 16. Technically, this is still a derivative. We're good, but we're going to simplify as much as possible. So we have dy dx is equal to, well, let's go combine our like terms, okay? 48 and negative 80, all right, they come together, and I'm trying to do that in my head right now. 2 is 50, 30. 32 is a negative 32, so you're negative 32x to the 7th. Now these have my highest degrees, so I'm going to deal with the 7th power first, okay? And so I put a little mark there showing that I've used those. And the next highest degree was the 6th, so x to the 6th power, so let's deal with that. 60 minus 24 comes out to be 40, it's 20, minus 4 is 36, 30 but a positive 36x to the 6th there, okay? Now we have x squared, my next one. So we subtract, there's nothing else, 48x squared, right there. And then the last part is plus 24x, okay? My denominator, okay, I see that I could probably pull out a common value from all parts here, all parts. And so if I can pull out a common value in all parts, what I can see is, well, I can pull out a 16 really from all of them. So let's go do that. Let's just go pull out 16. So 16 here, x to the 10th minus 2x to the 5th plus 1. Okay? So I pulled out 16, that's what would happen. Well, can I pull out a common term in all of these? Okay, the common term I can pull out, well, what goes into 32, 36, 48, and 24? Definitely 2, obviously, and another 2, right? So 4 can definitely come out of all of these, and that's where I think it's limited at. Okay, I believe it's 4. Yeah, 4 goes into all of them. So 4 is out here. I'm then left with a negative 8 x to the 7th plus we're pulling 4 out of all part. 4 goes into 36 9 times, so we have 9x to the 6th minus 48. 4 goes into 48 how many times? That's 12. 12x squared plus 4 goes into 24, 6 times 6x, all over here. Well, since I know 4 is the only part I can pull out, and 16 is really just 4 times 4. Okay, I'll put a 4 back in the inside part, so 4 times multiplying this other 4 inside, 4x to the 10th minus 8x to the 5th plus 4. Okay, so now our 4's will cancel, leaving me this being my final answer, my final derivative, my dy dx. I'm running out of room, so I'm going to leave it like that. And there we have it. We have this part here is my final answer. Negative 8x to the 7th plus 9x to the 6th minus 12x squared plus 6x all over 4x to the 10th minus 8x to the 5th plus 4. Y equals 3x to the 4th plus 2 all over 3x to the 3rd minus 2. My numerator, I'm going to label f, and so that's 3x to the 4th plus 2. And my denominator, I'm labeling g, 3x to the 3rd minus 2. I know with my quotient rule, I'm going to find f prime and g prime, so let's do that. F prime, product rule, or power rule, sorry. So we have 12x to the 3rd power, and g prime, again, power rule gives us 9x squared. So now let's go apply the quotient rule written up there, dy dx is equal to, well, f prime, 12x to the 3rd times g, which is 3x to the 3rd minus 2, minus f, which is, oh my goodness, I just wrote f, instead of the function f, or the part f that we have here, just wrote f down, 3x to the 4th plus 2 times g prime, which is 9x squared, all over my denominator squared, which is 3x to the 3rd minus 2 squared. So now let's go multiply this out. dy dx. 12 x to the 3rd times 3x to the 3rd gives us 36. We have 36x, add the exponent to the 6th power, minus 12 x to the 3rd times negative 2 is a negative 24 x to the 3rd. Now make sure we distribute this minus sign to both parts. Minus, well, 3x to the 4th times 9. 3 times 9 is 27. So we have 27, subtracting 27x to the exponent 6th power. Then minus again 2 times 9, which is 18x squared. All over, if you want to show a work for that right here, 3x to the 3rd minus 2, the denominator, 3x to the 3rd minus 2. To foil that, we have 9x to the 9th power, minus 6x to the 3rd, minus 6x to the 3rd, and you'll probably get better at this, we don't have to write it out. 9x to the 9th minus 12x to the 3rd plus 4, okay? We're doing all this together. Oh, not 9x to the 9th, sorry, that's the 6th power. Can't believe I did that. Be careful with that. We add the exponents, 6, okay? See if you caught that. If you caught that, put it in the comment section below. All right. So now I'm writing this out. We have 9x to the 6th power minus 12x to the 3rd plus 4. Okay? So do I have any like terms in the numerator? Let's see if I can simplify this and rearrange this. I'm trying to also think, is there a like term I can pull out? And 9, 12, and 4 have no common factors, so that I can maybe simplify something for up top. So there's no point necessarily pulling a common factor up top if there were any. And so when I rewrite my final answer here, dy dx, I'm going to combine my like terms. I have 36 and x to the 6, and then minus 27 x to the 6. Both of those x to the 6 power, I can combine those two. And so 36 minus 27 comes out to be 9. Okay, right? 9, yeah. So we have 9 x to the 6th power. I use these two up. Now the third power is left, minus 24 x to the third minus 18x squared. All over my denominator, 9x to the 6th minus 12x to the third plus 4. And there we have our final answer and our derivative. Y equals 4x to the 5th plus 2x squared all over 3x to the 4th plus 5. Well, I'm going to label my numerator my f, which is 4x to the 5th plus 2x squared, and my denominator g, 3x to the 4th plus 5. So now I have f over g. I can see that I could apply the quotient rule here. I have two functions being divided as part of one big function. So let's go find f prime. F prime is equal to 20x to the 4th plus 4x, and g prime comes out to be just 12x to the 3rd. So now I have f prime, g prime. Let's apply our quotient rule written right there. dy dx equals f prime, which is 20x to the 4th. So now it's just a plug and chug kind of thing, times g, which is 3x to the 4th plus 5, minus f, which is 4x to the 5th plus 2x squared, times g prime, which is 12x to the 3rd. All of that over my denominator, which is g squared, so we have 3x to the 4th plus 5 all squared. So at this point, I've finished my calculus. I now just need to apply algebra, so we'll be distributing and simplifying. So we have dy dx here. 20 times 3 is 60, so we have 60. And then we add the exponents, x to the 8th power, plus 20 times 5, okay, is 100. So we have 100x to the 4th. Then 4x times 3x to the 4th power. We have 12 here, x to the 5th power. And then 4x times 5 is 20x. Now when we subtract here, make sure we distribute the subtraction to all parts there. And sometimes it's easier to kind of see it like this. Make a plus and make the negative right there by the 12. X to the 3rd, you can see it like that. That makes it easier for you. Or you can leave it and distribute it how you may. But it's just, I just find it easier like that sometimes. Okay, just double checking I did everything here. For some reason I'm thinking I messed up. It doesn't look like it. Okay. So let's distribute now. 4 times a negative 12. That's a plus a negative here now. 4 times 12 is 48, so we have negative 48. Add the exponent, x to the 8th power. And then 2 times negative 12 is a negative 24. And that's x to the 5th power when we add the exponents. All over my denominator, I can simplify over here. 3x to the 4th minus plus 5 times 3x to the 4th plus 5. When I multiply that out, 3x to the 4th times 3x to the 4th is 9x to the 8th plus 15x to the 4th plus 15x to the 4th. You'll get better at this. The faster you do it, the more you do it, plus 25. Simplify 9x to the 8th plus 30x to the 4th plus 25. Okay, so we have 9x to the 8th plus 30x to the 4th plus 25. Okay, so now let's go simplify. Let's find my like terms and combine them. Okay, so we have dy dx equals, our highest degree I see is the 8th power, so I'm going to combine these two together. They're right there, okay. 60 minus 48 is 12, so we have 12x to the 8th power. Next highest degree I see is to the 5th power. 12x to the 5th minus 24x to the 5th is a negative 12x to the 5th. Okay, find those two. Next highest exponent I see is the 4th power, so we have plus 100x to the 4th right there. And do I see anything else? Fourth, third, second. Okay, last one is 20, just x, plus 20x. And I believe I have all of them brought down. Fantastic. Now my denominator, simplify it out here, or rewrite it. 9x to the 8th plus 30x to the 4th plus 25. Okay? And there's nothing I can really simplify here. No like terms I can pull out of the numerator and denominator, not that I'm aware of. And it's not the end of the world, to be honest. I didn't really mark off my students if they didn't, find something else to factor out. I was pretty happy with this. So we have our final derivative here of dy dx equal to 12x to the 8th minus 12x to the 5th plus 100x to the 4th plus 20x all over here, 9x to the 8th plus 30x to the 4th plus 25. Y equals 4x to the 5th plus x squared plus 4 all over 5x squared minus 2. So I see I have a quotient here. I'm going to label my numerator f, which is 4x to the 5th plus x squared plus 4, and my denominator g, 5x squared minus 2. And then I'm going to find f prime and g prime. F prime is just 20x to the 4th plus 2x, and g prime is just 10x. Okay? Double checking that. Yep, we're good. We're good. So then from there, I'm going to find now my derivative, dy dx, and I'll apply my quotient rule. F prime, writing first, 20x to the 4th plus 2x times g, which is 5x squared minus 2, minus f, which is 4x squared to the 5th power, plus x squared plus 4, times g prime, which is just 10x, all over g squared, 5x squared minus 2 all squared. So now let's go simplify. At this point, I've already done my calculus, so the rest now is just algebra. So here's my derivative. So let's simplify that now. dy dx, make it look a little cleaner. 20x to the 4th times 5x squared is 100. X to the, add the exponent 6th power. 20 times a negative 2 is a negative 40x to the 4th. 2x times 5x squared is 10 plus 10x to the 3rd. And 2x times a negative 2 is a negative 4x. Okay? Now, we make sure we distribute this minus sign. I find it easier sometimes to just put it right here with that negative 10 when I multiply it out so I don't forget it. So 4x to the 5th times negative 10 is a negative 40x to the 6th power. We add the exponent. X squared times negative 10x is plus a negative 10x to the 3rd. And then 4 times negative 10x is a negative 40x. All over my denominator, which I'm going to simplify right here. 5x squared minus 2 times 5x squared minus 2. Hopefully you're getting better at that. Multiply them out here. I have a 25x to the 4th minus 10x squared minus 10x squared plus 4. We have 25x to the 4th plus 20x squared plus 4. So I'm going to write that right here. 25x to the 4th plus 20x squared plus 4. So now when I simplify this, I'm going to rearrange my like terms as my numerator and combine them. So we have dy dx. My numerator, I see the highest power I have is the 6th power. So 100x to the 6th plus a negative 40x to the 6th is 60x to the 6th power. Okay, mark them so I know that I've used them. Now the next highest degree I see is the 4th power. There's only one of them. So we have minus 40x to the 4th right there. Then the next highest power I see is to the 3rd power, plus 10x to the 3rd, plus minus 10x to the 3rd. I wrote it down before simplifying. Okay. Well, we have 10x to the 3rd minus a 10x to the 3rd. Combine them, they cancel out, so I don't actually write anything there. Got a little ahead of myself. Then I have negative 4x plus a negative 40x. That's a negative 44 or minus 44x. All over my denominator, 25x to the 4th plus 20x squared plus 4. And there we have our final answer. Let's double check in here, making sure everything's right. Looking good, looking good, looking looking good. Why do I have a minus down there? Oh my goodness. Quick mistake here. Let's just go fix it. Can't believe I did that. Negative 10x squared minus 10x squared, it's a negative. I missed that. It happens sometimes. I get ahead of myself, thinking everything's positive. So we have 25x to the fourth minus 20x squared plus 4. So that is actually our final answer. If you caught that, I bet you were watching that thinking about it like, oh, what's he doing? What's he doing? Fix it right there. So put in the comment section below if you caught that mistake. dy dx, it's okay. We all make mistakes, right? dy dx is equal to 60x to the 6th minus 40x to the 4th minus 44x all over 25x to the 4th minus 20x squared plus 4. Caught it before I get to the end of the video. That's good. Y equals 3x to the 4th plus 5x to the 3rd minus 5 over 2x to the 4th minus 4. Okay? Well, I'm going to label this f over g. So if f is my numerator, read right here, equals 3x to the 4th plus 5x to the 3rd minus 5. By denominator being g, 2x to the 4th minus 4. So let's go find f prime and g prime here. F prime is just 12x to the 3rd plus 15x squared. And g prime is just 8x to the 3rd. Okay. So now let's go apply our quotient rule. So we have dy dx here. First I need to put f prime, which is 12x to the 3rd plus 15x squared. Okay. Times g, which is 2x to the 4th minus 4, minus f, which was 3x to the 4th plus 5x to the 3rd minus 5, times g prime, which is 8x to the 3rd, all over g squared, 2x to the 4th minus 4 all squared. Okay? So at this point, we've taken our derivative. We need to simplify this. We're going to multiply everything out. So we have dy dx here. Let's go multiply that out. 12x to the 3rd times 2x to the 4th is 24x to the 7th power. 12 times a negative 4 is a negative 48. So we have negative 48, x to the 3rd power. Now we have 15 times 2 is 30. So we have 30. We add the exponents. That's x to the 6th power. And 15 times negative 4 is negative 60, and that's x squared. This minus sign I'm going to distribute and put it over here to the negative 8, or make it 8 negative so I don't forget it. Let's distribute this now. 3 times negative 8 is a negative 24. We add the exponent, which is x to the 7th power. 5 times 8 is 40, so it's a negative 40, so negative 40. X to the 6th power, we add the exponents again. And negative 5 times 8 again is negative 5 times negative 8 is a positive 40 x to the 3rd. My denominator, I'm going to rewrite over here to simplify it on its own. So we have 2x to the 4th minus 4 times 2x to the 4th minus 4. Multiplying that out, we have 4x to the 8th minus 8x to the 4th minus 8x to the 4th plus 16. Simplifies to be 4x to the 8th minus 16x to the 4th plus 16. Okay, make sure I did all that right and looks good. So rewrite that down here. 4x to the 8th minus 16x to the 4th plus 16. So now let's go simplify my numerator. dy dx is equal to, let's go find my highest degrees first and see and combine them. Well, 24x to the 7th, I say 7th highest power, so 24x to the 7th plus a negative 24x to the 7th. When I combine these two, they eliminate each other, so we're kind of done with those two. Now let's go to the next highest power is the 6th. 30x to the 6th power plus a negative 40x to the 6th. Those two can be combined to be negative 10. So we have negative 10x to the 6th power right there. Then I see next highest degree is the 3rd power, right? 6. All right, and we have 7, 6. So we have no 4, 5, no 4, so we have 3rd power. Negative 48 and positive 40 is a negative 8, so we have negative 8x to the 3rd right there. And then lastly, it's just negative 60x squared. All over my denominator here. which is 4x to the 6th minus 16x to the 4th plus 16. Now, I can see that all of these are even, and so I can probably pull something out and simplify this a little bit more, but I'm pretty happy with the answer as it is. Don't need to simplify it anymore if you don't mean. You can, it's usually nice. Most teachers maybe want it. I never really cared at this point. If you got it down to this, I was pretty happy. And so my final answer here is dy dx is equal to negative 10x to the 6th minus 8x to the 3rd minus 60x squared over 4x to the 6th minus 16x to the 4th plus 16. Y equals x to the 3rd minus x squared minus 3 all over x to the 5th plus 3. Okay? Well, my function here is really a function divided by another function. Since we have that, I'm going to label my numerator f x to the 3rd minus x squared minus 3. My denominator g, x to the 5th plus 3. Then I need to find, okay, so now that I have f and g, f over g, let's go find f prime and g prime. So f prime, take the derivative of f, which is 3x squared minus 2x, and take g prime to be 5x to the 4th power, okay? So we have g equals x to the 5th plus 3, and g prime being 5x to the 4th. Now, we need to apply the quotient rule here, so dy dx here. Let's go apply the quotient rule. Written right there, we start with f prime, which is 3x squared minus 2x, times g, and g came out to be x to the 5th plus 3, subtracted by f, which is x to the 3rd minus x squared minus 3, times g prime, which we found, 5x to the 4th. And that's going to be written all over g squared, which is x to the 5th plus 3, all squared. Okay? So now that we have everything here, we need to, at this point, we basically have done our calculus. So now we need to simplify. So when I'm simplifying here, dy dx, I'm rewriting my derivative. Let's distribute the 3x across. So we kind of distribute all parts FOIL, if you will, for this part here. 3x squared times x to the 5th is 3x, we add the exponent, 7th power. 3 times 3 is 9, so we have plus 9x squared. Negative 2x times x to the 5th is negative 2x to the 6th power. Again, we add the exponent. And then negative 2x times 3 is a negative 6x. Now make sure we remember to distribute that this minus sign now. So everything here is being subtracted. What I like to do is I kind of make that a plus and put that minus sign with, especially if I see an individual unit that's being multiplied out. I find it easier. It's up to you. But let's go distribute now. X to the 3rd times a negative 5x to the 4th. That's a plus a negative 5x to the 7th power. Negative x squared times a negative 5x to the 4th is a positive 5x to the, we add the exponent, 6th power. And then negative 3 times negative 5 is a positive 15. And that's x to the 4th power. Okay? Now that denominator there, I can simplify it. I like to kind of write on the side here. Let's go multiply x to the 5th plus 3 times x to the 5th plus 3 because it's squared right there. So we have x to the 5th plus 3 times x to the 5th plus 3. Multiply that out. We have x to the 10th plus 3x to the 5th plus 3x to the 5th plus 9. And that comes out to be x to the 10th plus 6x to the 5th plus 9. Okay? So I'm writing down here x to the 10th plus 6x to the 5th plus 9. So now let's go simplify our numerator. Let's combine our like terms and put our highest degrees first. So we have our dy dx here. Well, our highest degrees I see is the 7th power. We have 3x to the 7th and negative 5x to the 7th. So if I combine those two, let's go mark them, show that I've used them. That's going to be a negative 2x to the 7th power. Okay? Next highest degree is the 6th power. We have a negative 2x to the 6th and a 5x to the 6th I see. So that's a positive 3x to the 6th. And again, let's mark them to show that we've used them. Okay, after the 6th power, I don't see anything to the 5th power. Fourth power, I see 15x to the fourth, so we have plus 15x to the fourth power right there. I don't see anything to the third power. The second power, I see a 9x squared. And then to the first power, the only thing I see is negative 6x, so we go minus 6x right there. And that's going to be all over our denominator, x to the 10 plus 6x to the 5th plus 9. Just double check, make sure I got everything. Oh, I'm solving it correctly. Looking good. So here's our final answer, our final derivative. dy dx is equal to a negative 2x to the 7th power plus 3x to the 6th power plus 15x to the 4th plus 9x squared minus 6x all over x to the 10th plus 6x to the 5th plus 9. Y equals x to the 4th plus 6 over 3 minus 4x to the negative 4th power. Okay? And that negative 4th power should give us a little pause for a second. This is going to be a little more difficult than a normal quotient rule. So, using the same process here, my numerator I'm labeling f to be x to the 4th plus 6. My denominator g to be 3 minus 4x to the negative 4th power. Okay? Then from there, I want to find f prime. So f prime here is derivative of f for x to the 3rd. And g prime here, derivative of g, is just going to be positive. All right, remember the negative comes down, negative times the negative positive 16, x to the negative 5th power. Okay, so it's positive 16, and we don't really need to write that though, the plus sign. Okay. So now we apply the quotient rule, dy dx here. So apply that quotient rule. F prime comes first, 4x to the 3rd power, parentheses that are around it, times g, which is 3 minus 4x to the negative 4th power, minus f, which is x to the 4th plus 6, times g prime, which is 16x to the negative 5th. Okay? So now, I need to put that all, don't forget the bottom part, put it all over g squared, which is 3 minus 4x to the negative 4th power squared. So now let's go simplify. So we've done our calculus, we've taken our derivative, now let's go simplify. So we have dy dx here. See if I can simplify this. We'll distribute the 4. So the 4 times the 3 is a 12. So we have 12. And then it's x to the 3rd power. Distribute the x to the 3rd. Minus 4 times 4 is 16. And then we add the exponents, x to the 3rd plus x to the negative 4th. The exponent is 3 plus negative 4 is a negative 1. So we have x to the negative 1 power. Now we deal with this one here. Make sure we distribute the minus sign. So x to the 4th times 16x to the negative 5th. That's going to be a minus 16, and we add the exponents together. 4 plus negative 5 is negative 1, so we have x to the negative 1 there, and distribute the 6 times 16, which I believe is 96. We have negative 96 here, x to the negative 5th power. Okay, let me double check that really quickly just to make sure I don't make mistakes. I make any mistakes. 6 times 16 is 96, yes. All of that is over denominator, which I'll simplify over here. Okay, we have 3 minus 4x to the negative 4th power times 3 minus 4x to the negative 4th power. 3 times 3 is my 9. 3 times negative 4 is negative 12. X to the negative 4th power. And then negative 4 times 3 is negative 12. X to the negative 4th power. Okay. Then negative 4 times negative 4 is a positive 16. And that's x. We add the exponent to the negative 8 power. Okay? So if I combine these two, which I'm going to do that right here, I'm going to combine these two to get negative 24 there, we have 9 minus 24x to the negative 4th power plus 16x to the negative 8. Okay? Well, at this point, I can simplify this a little bit. I can combine my like terms right there. Then I see x to the negative 1s. I can combine them. So we have dy dx here equals 12x to the 3rd minus 32. X to the negative 1 minus 96x to the negative 5th all over 9 minus 24x to the negative 4th plus 16x to the negative 8. Okay? Well, I know what you're thinking right now, saying, we can't have negative exponents in our denominator. How are we going to eliminate that? Some teachers are okay at this point. They say, you're good, don't worry about it. What I'm going to recommend right here, ready, is what can I multiply? I can maybe multiply this whole thing by, well, we multiply by 1, it doesn't change it, right? But if I multiply by something that looks or doesn't look like 1 but really is 1, like a number over itself, can I eliminate some of these negative exponents? And what if I multiplied the whole thing by, our highest degree is at x to the negative 8. But if I multiply the whole thing by x to the 8 over x to the 8, this whole thing over here, if I did that, I would get, well, 12. So we distribute the x to the 8 times the 12. We'd have 12 x to the 11th power, right? We add the exponents. 8 plus 3 is 11. Minus 32. It doesn't really change the coefficients. And then, well, negative 1 plus 8 is x to the 7th, right? Minus, 96. Add the exponents, x to the 3rd power. All over. Distribute again down here. 9x to the 8th power minus 24. Negative 4 plus 8 is a positive 4. X to the 4th power plus 16. And negative 8 times 8, or plus 8 is 0. So we just have just plus 16. And that's it. That's equal to our dy dx. And now we have a final answer that doesn't have an exponent in exponent that's negative anywhere. Okay? And so let me just double check here, and we're good. Making sure. Fantastic. So our final answer here is dy dx is equal to 12x to the 11th minus 32x to the 7th minus 96x to the 3rd all over 9x to the 8th minus 24x to the 4th plus 16. Y equals 4x to the 4th power minus 4x squared plus 5 all over 2x to the 5/3 power plus 3. Okay? Well, I see I have a quotient function here. Okay? A top divided by a bottom. The top let's label as f, which is 4x to the 4th minus 4x squared plus 5. And the bottom being g, 2x to the 5/3 plus 3. So when I find f prime here, I want to find f prime and g prime. F prime is 16x to the 3rd minus 8x. I'm using the power rule there. G prime comes out to be, well, the 5/3 comes down. 5/3 times 2 is 10/3, so 10/3 x to the, subtract the exponent by 1 to the 2/3 power, and we don't really worry about the constant. So now we have f prime, g prime. We can apply the quotient rule. So dy dx here. Apply the quotient rule, f prime, which is 16x to the 3rd minus 8x, times g, which is 2x to the 5/3 power plus 3, minus f, 4x to the 4th minus 4x squared plus 5, times g prime, which we found to be 10/3, x to the 2/3 power. All over my denominator, squared, which is 2x to the 5/3 plus 3 squared. So just like every other problem, don't let the fractional exponents scare you here. Let's go distribute everything out here and simplify. But at this point, we've done our calculus. This step, we found a derivative. It's kind of crazy, but we have found our derivative. So everything after this point is really just practicing on algebra. So we have dy dx here. Let's distribute out underneath. 16 times 2 is 32. So 32. We add the exponents. Now this is tricky. 3 is the same thing as 9 over 3. Okay? So if we add the exponents, well, 3 is being 9 over 3. Okay, 9 plus 5 is 14. So we have actually 14/3 as our exponent here. 16 times 3. Oh, I believe 16 times 2 is 32. Add another 16. That's going to be a 48. So we have a 48x to the 3rd power there. Now, negative 8 times 2 is a negative 16. we add the exponents, just add 3 over 3 there, and 5 plus 3, all right, because x to the first power is 3 over 3, so 3 plus 5 is 8, so we have 8 x to the 8/3, don't forget your variable x, John, x to the 8/3 power. And then negative 8 times 3 is a negative 24, okay, and that's just negative 24x. So this negative sign, the subtraction, let's distribute over to here. I like to do that, especially if I have a single term being multiplied. So now let's go be careful when we simplify this out here. Okay, 4 times 10 is a 40, so we have a negative top, so we have a negative plus a negative 40 over 3 x to, then we add the exponents, right? So a 4 is the same thing as 12/3, so we have a 14/3 here, 14/3, okay, as our exponent power. Then we have lastly, or not lastly, so distribute that one across, distribute this one across, plus a negative 4 times 10 is or not a negative, because we have a negative times a negative, which is a positive. So 4 times 10 is 40, so we have 40 over 3. We add the exponents, that's x to the, well, 2 is the same thing as 6 over 3 when we're adding the fraction there. So we have 8 over 3. So we have x to the 8/3 power. And then distribute the last part 5, so 5 times that plus a negative 50 over 3 x to the 2/3 power. All of that is over our denominator, which I'm going to simplify right here. Hopefully we have enough room here. This is a big problem, okay? So we simplify that, and we have, well, 2x to the 5/3 plus 3 times 2x to the 5/3 plus 3. Okay? Then from there, we distribute that out. 2 times 2 is 4, so we have 4x to the, now we add the exponent, that's going to be 10/3 plus 2 times 3 is 6, 6x to the 5/3. Here, 3 times 2 is 6, x to the 5/3, and 3 times 3 is 9. Okay? So I'm going to combine these two when I write it down here. I have 4x to the 10/3 plus 6 plus 6 is a 12. Okay, so we have 12x to the 5/3 power plus a 9. Okay? Making sure we're looking good there. Okay? Okay? So now we need to simplify this. We need to combine our like terms. Okay? And this one becomes a little tricky in how we're doing this. There's a few ways we can go about it. What we can do, if we don't really like to see this third, everything over like the third power, what I can do is multiply the numerator and the denominator together all by 3. So I get 3 over 3. And what that kind of does, all right, it kind of helps simplify things. So multiply the whole thing 3 over 3 is really multiplying by 1. What that does is when I multiply it out, okay, we can see what's going to happen. It's going to eliminate a lot of these 1/3 coefficients, which really help me simplify. So what I'm going to do here, especially on the numerator part, is I'm going to kind of distribute that 3 across. So I'm going to kind of show the step here where I'm going to be multiplying that 3 across, because I'm running out of space there. So 3 times is 3. That's going to eliminate this, this, this. 24 times 3, oh, I should know this off the top of my head, but going blank, 72. So this becomes a negative 72. This coefficient, 16 times 3, should be a negative 48. 48 times 3 is a 144. And 32 times 3 is a 96. Our denominator is going to be easy to show on our last step, so I'll wait till then to do it. But I'm multiplying the numerator by that 3. Okay? And so now when I combine them, I don't have to worry about adding those fractions. I've already eliminated a lot of those fractions right there by multiplying by 3 over 3, essentially 3 across there, and I'll do 3 on my next step. So by doing that, I can find my like terms. Okay, what is my highest exponent I see? And it's kind of tricky here, but I see the 14/3 is my highest exponent, so we combine them. 96 minus 40, which was left there, is going to be just a 56, right? So we have 56 x to the 14/3 power. So let's mark those to show that we've got them. So now my next highest degree, okay, is, I believe, is just the x to the 3rd power. Yeah, because it's just higher than 8/3. There's only one of them. It's 144, so we have plus 144 x to the 3rd power. Brought that down. Next is my 8/3 power. Well, I have negative 48 plus a 40. Okay, so that's a negative 8, so negative 8 x to the 8/3 power. Mark these two right there. Then what's next? I have to the 1st power. Negative 72 is just by itself, so the negative 72 x to the 1st power. And then lastly, I have to the 2/3 power, and that's a negative 50 x to the 2/3 power. Okay? Let's double check I got everything. I think I did it. That is correct. All over, now let's not forget to distribute that 3 toward the denominator. 3 times 4 came out to be 12x to the 10/3 plus 3 times 12 is 36, so we have 36x to the 5/3 power plus 3 times 9, which is 27. And now here we have our crazy final answer, our derivative here. If I can make sure I circle it, I don't cross anything out. And we have dy dx is equal to 56x to the 4/3 power plus 144x to the 3rd power minus 8x to the 8/3 power minus 72x minus 50x to the 2/3 power all over 12x to the 10/3 power plus 36x to the 5/3 power plus 27. I know it's a lot of work there. This little trick there does help eliminate a lot of those fractions, especially for like, how do I add that? Negative 40 over 3 plus 32. Don't want to deal with it. Multiply it over 3 over 3, the whole thing. Kind of eliminate that. It's like a nice little trick there. Take your time with this. I know I kind of combined some steps together. So take your time, pause the video, see if you can recreate what we did right here. A classmate claims, what a claim, that f over g all prime, right, is equal to f prime over g prime for any function f and g. Over here, f and g. Show an example that proves your classmate wrong. So we're going to prove our classmate wrong, and we're showing examples. So if we just find one, my claims looks funky. There we go. So we're going to prove our classmate's wrong, and we're show just basically one example where they're wrong. Just find one example where it's could be wrong. So if I have f to be 4, let's pick f to be 4, and g to be 2x. If I find f prime is 0 and g prime is just 2. Okay? And sometimes it's easy to keep it simple. No sense in making a really hard problem here. We're going to find one simple way where this is wrong. Okay? So if I wanted to find f over g prime, that's like our quotient rule. Okay? That's a rule that we know. So I'm going to apply that. I'm going to take my f over g all prime, and that's going to be applying the quotient rule right down there. So I'm going to put that here first on the left, and that's going to be f prime, which is 0, times g, which is 2x, minus f, which is 4, times g prime, which is 2, all over g squared, which is 2x all squared. So on the right-hand side, they've said, okay, what about f prime over g prime? So that's what I'm going to put 0 over 2. Okay? So now I have my f prime over g prime right here. And then I have my quotient rule, which is f over g all prime, which I set up right there, and I apply the quotient rule right here. So let's simplify this. Each side, don't bring anything over the equal sign. We're going to see if they are equal on both sides. 0 times 2x is 0. So we have 0 minus 4 over 2, 4 times 2, which is 8. So we really don't need that 0 there. Let's eliminate that. We have a negative 8 up top. Okay? Negative 8 up top in the denominator. 2x squared is a 4x squared. Okay? that equals 0. 0, 2, 0. Do they equal? No, they don't, right? Now we could simplify this one more if I really, really wanted to. 4 and 8 is just, that's the same thing as like a -2 over x squared equals 0 if I want to simplify it. At this point, we really can clearly see that they're not equal, right? So they're not equal, so since my left and right are not equal, we can't make this claim. We've already found one case where it's not true, so we can't make the claim that it works, that f over g all prime is equal to f prime over g prime. So our classmate is wrong.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.